In this video, we're going to complete the Solving by Completing the Square worksheet on the KutaSoftware website under the Infinite Algebra 1 section, picking up where we left off with number 17. For number 17 at the start, my a value you can see is a positive 7, so I'm going to divide both sides by 7 in order to get an a value of 1 so that I can complete the square. Now, dividing the right-hand side by 7, 0 divided by 7 is simply 0. The left-hand side, I'm going to divide 7 to each of the terms. So 7b squared divided by 7 is b squared, or 1b squared, minus 14b divided by 7 is 2b, minus 56 divided by 7 is a positive 8. Now I'm going to move that constant to the right-hand side of my equation by adding 8 to both sides. Negative 8 plus 8 is 0, and then I'll have b squared minus 2b equal to positive 8. Now I can complete the square on my left-hand side. My b value is a negative 2, and c is b over 2 squared. So that will be negative 2 over 2 squared, which is a negative 1 squared, which gives me a positive 1. So I'm going to add 1 to both sides, adding c to the left and c to the right. So b squared minus 2b plus 1 equals 8 plus 1. Whatever I do to the left, I do to the right. Adding 1 to the left, I'll add 1 to the right. So I'll be able to rewrite that as a minus b squared. However, in this case, my b in my equation is equivalent to my a value, so I'll have b, and then I'll be subtracting my b value of 1 squared. So again, what I'm doing, that's in the form of a squared minus 2ab plus b squared, which I can rewrite as a minus b squared. However, in this equation, my a value is equivalent to b, and my b value in the formula is equal to a positive 1. So this b represents the b in my equation, and this b represents the b in my formula. So I'll have b minus 1 squared equals 8 plus 1, which is 9. So I'll take the square root of both sides. That means that b minus 1 is going to equal either positive or negative 3, since the square root of 9 is positive 3 and negative 3. So for b minus 1 equal to positive 3, I'll add 1 to both sides to get that b is equal to a positive 4. And for b minus 1 equal to negative 3, I'll add 1 to both sides to get that b is equal to a negative 2, since negative 3 plus 1 equals negative 2. So my solutions in number 17 are positive 4 and negative 2. Continuing on to number 18, I'll start by dividing everything by 2. So dividing my left-hand side by 2 and dividing my right-hand side by 2. Dividing each of those terms by 2, 2n squared divided by 2 is 1n squared, or simply n squared. 12n divided by 2 is 6n, and 10 divided by 2 is 5. And that's all equal to 0 divided by 2, which is 0. So now I'll subtract 5 from both sides, moving my constant to the other side of the equation. So I'll have n squared plus 6n equal to a negative 5. Now I'll be able to complete my square on the left-hand side of my equation, since I have just my ax squared term and my bx term. So if my b value is a positive 6, my c value is going to equal 6 over 2 squared, which is 3 squared, which equals 9. So I'm going to be adding 9 to both sides of my equation. N squared plus 6n plus 9 equals negative 5 plus 9. So I'll rewrite n squared plus 6n plus 9 as n plus 3 squared. That's a plus b squared, because a squared plus 2ab plus b squared, that's the form of n squared plus 6n plus 9. And that's equal to negative 5 plus 9, which is a positive 4. Now I'll take the square root of both sides. So n plus 3 will either equal the positive square root of 4, which is 2, or n plus 3 is going to equal a negative square root of 4, which is negative 2, since negative 2 squared equals positive 4 and 2 squared equals positive 4. So I'll subtract 3 from each side of both those equations in order to isolate my n. So n will equal 2 minus 3, which is negative 1, and n will equal negative 2 minus 3, which is negative 5. So my solutions for number 18 are negative 1 and negative 5. In number 19, my a value is a positive 1, so I'm not going to need to divide. However, I need to move this constant of 22 to the other side of the equation, and I'll do so by subtracting 22. So I'll have n squared plus 13n equal to 7 minus 22, which is a negative 15. Now I'll complete the square on my left-hand side. If my b value is a positive 13, my c value will equal 13 over 2 squared, which 13 divided by 2 is a positive 6.5, and if we're squaring that, 6.5 squared equals 42.25. So I'm going to add 42 and 25 hundredths to both sides. So I'll have n squared plus 13n plus 42.25 equal to negative 15 plus 42.25. Note, 6.5 times 2 is 13, and 6.5 squared is 42.25. So we'll have n plus 6.5 and that quantity squared. That's going to be equal to negative 15 plus 42.25, which is a positive 27.25. So now we're going to take the square root of both sides. So n plus 6.5 equals either positive or negative square root of 27.25. So when n plus 6.5 equals the positive square root of 27.25, subtracting 6.5 from both sides, we'll get that n is equal, typing that into our calculator, the square root of 27.25 minus 6.5 will equal negative 1.2798, which on our worksheet they round that to negative 1.279, but I'm going to round that to negative 1.280. So negative 1.280, and for n plus 6.5 equal to negative square root 27.25, I'll subtract 6.5 from both sides to get that n is equal, typing that into my calculator, a negative 11.7201, which rounds to negative 11.72. So my solutions in number 19 are negative 1.28 and negative 11.72. Moving on to number 20, my a value is a positive 5, so eventually I'm going to need to divide by 5. But before I do that, I'm going to add 68 to both sides. So I'll get 5n squared plus 19n equal to negative 2 plus 68, which is a positive 66. Now I'll divide everything by 5, the left-hand side and the right-hand side. 5n squared divided by 5 is a positive n squared, and I'll add that to 19n divided by 5, which is 3.8n, and that will equal 66 divided by 5, which is 13.2. Now I need to complete that square on my left-hand side. My b value is a positive 3.8, so my c value will equal 3.8 over 2 squared, which 3.8 divided by 2 is 1.9, and when I square that, I'll get 3.61. So remember that my b squared value is going to be 1.9 squared. So I'll have n squared plus 3.8n plus, and I'll leave this as 1.9 squared, equal to 13.2 plus 3.61. And I'll leave that as 1.9 squared just to show you that that is indeed the b squared value, which makes it easier when I split it up. Now, since this is n squared plus 2ab plus b squared, I can just write n plus 1.9 and that entire quantity squared. I also could have written 3.61 as 1.9 squared, but since I'm adding it to 13.2, ultimately, in the end, it doesn't matter how you write the numbers, just know that they're equivalent. So 13.2 plus 3.61 equals 16.81. So I'm going to take the square root of both sides. That means that n plus 1.9 equals the positive square root of 16.81, or n plus 1.9 equals negative square root of 16.81. So in both equations, I'm going to need to subtract 1.9 from both sides in order to isolate my n value. So in that first equation, n, when I take the positive square root of 16.81 and I subtract 1.9, I'll get a positive 2.2. And in that next equation, my n, when I take the negative square root of 16.81 and subtract 1.9, I'll get a negative 6. And that's because the square root of 16.81 equals 4.1. So 4.1 minus 1.9 equals 2.2, and negative 4.1 minus 1.9 is a negative 6. So my solutions in number 20 are 2.2 and negative 6. In number 21, I know I'm not going to need to divide. However, I need to move that constant to the other side of my equation, and I'll do so by adding 38. So I'll have r squared minus 9r equal to negative 9 plus 38, which is a positive 29. Now I'm going to need to complete the square on my left-hand side. So my b value is a negative 9, so my c value will equal negative 9 over 2 squared. Negative 9 divided by 2 is a negative 4.5, and when I square that, I'll get 20.25. So adding 20.25 to both sides, I'll have r squared minus 9r plus 20.25 equal to 29 plus 20.25. So you can see my b squared value was 4.5 squared, and because I'm subtracting 2ab, I'll write this as r minus 4.5 squared, and that will equal 29 plus 20.25, which is 49.25. So now I'll take the square root of both sides to get that r minus 4.5 will equal a positive or negative square root of 49.25. So r minus 4.5 equals a positive square root of 49.25. I'll solve that by adding 4.5 to both sides. So taking the square root of 49.25 and adding 4.5, we'll get 11.5178, which on the worksheet they round to 11.517, but I'm going to round up to 11.518. So r equals 11.518, and we're going to see when r minus 4.5 equals negative square root of 49.25. So now we'll add 4.5 to both sides, and adding 4.5 to the negative square root will give us negative 2.5178, which again they rounded down to negative 2.517, but I'm going to round up to negative 2.518. So my solutions in number 21 are positive 11.518 and negative 2.518. Let's continue on to number 22. In number 22, my a value is something other than 1. So I'm going to need to divide everything by 3. However, before I do that, I'm going to subtract my constant. So I'll have 3x squared plus 20x equal to 4 minus 36, which is a negative 32. So now I'm going to divide everything by 3. 3x squared divided by 3 is positive 1x squared. 20x divided by 3 is 6.66 repeating, so I'll just leave that as 20 thirds times x, 20 over 3 times x, and that's equal to negative 32 divided by 3, which is negative 10.6 repeating. So again, I'll leave that as negative 32 over 3, so that when I type those into my calculator, within parentheses, I'll have those exact values as opposed to a rounded value so soon within my problem. Now I need to find my c value that I'm going to add to each side. And if b is equal to 20 over 3, my c value, remember, is b divided by 2, which dividing by 2 is the same as multiplying by 1/2. So I'm going to have 20 over 3 times 1/2 squared. And that's going to be 20 over 6 squared, which 20 divided by 6 is the same as 10 over 3. And when I square 10 thirds, I'll get 11.1 repeating, so 11.111. So now I'm going to add my c to both sides. So I'm going to have x squared plus 20 thirds x plus, and then I'll put 10 thirds squared. That's going to be equal to negative 32 over 3 plus, and again, just in order to keep this as exact values, I'll write 10 thirds squared, which we know is equal to 11.1 repeating. So I can rewrite this as x plus 10 thirds squared, since it's in the form of a squared plus 2ab plus b squared, and that will be equal to negative 32 thirds plus 10 thirds squared, which is 4/10 repeating, 0.4444, which I'll leave in fraction form as 4/9. And why I'm leaving this in fraction form is because when I take the square root of both sides, I'll get that x plus 10 thirds is going to be equal to a positive square root of 4/9 or a negative square root of 4/9. I'll write as the square root of 4 over the square root of 9, and this is either positive or negative. So x plus 10 over 3 equals a positive 2/3 or it equals a negative 2/3, since the square root of 4 is 2 and the square root of 9 is 3. So I'll solve for when x plus 10 thirds equals a positive 2/3. What I'll do, I'll subtract 10 thirds from both sides, and because they have a common denominator, I'll be able to subtract. So I'll get that x equals 2/3 minus 10 thirds is negative 8/3, which as a decimal, negative 8/3 is negative 2.6 repeating, so negative 2.66, and on the worksheet, they round that third value to 6, but I'm going to round up to 7, so negative 2.667. So that's solving when it's equal to positive 2/3. Now let's solve when it's equal to negative 2/3. When x plus 10 thirds equals a negative 2/3, we'll subtract 10 thirds from both sides to get that x is equal to negative 2 over 3 minus 10 over 3, which is negative 12 over 3, which simplifies to negative 4, since 3 goes into 12 evenly. So my two solutions in number 22 are negative 2.667 and negative 4. Moving on to number 3, my a value is a positive 1, so I'm not going to need to worry about dividing by a. However, I need to move this constant to the other side, and I'll do so by adding 45 to both sides. So I'll get x squared plus 7x equal to 7 plus 45, which is 52. So now I'm going to complete my square on my left-hand side. If my b value is 7, my c value is going to be 7 over 2 squared, which 7 divided by 2 is equal to 3.5, and when we square that, 3.5 squared equals 12.25. So I'm going to add 12.25 to both sides, that c value, so I'll take x squared plus 7x and add 12.25, and that will equal 52 plus 12.25. So rewriting a squared plus 2ab plus b squared, I'll have x plus 3.5, since 3.5 squared was 12.25, so a plus b squared equals 52 plus 12.25, which is 64.25. Now I'm going to be taking the square root of both sides. So x plus 3.5 equals positive or negative square root of 64.25. So I'll have that x plus 3.5 equals the positive square root of 64.25, and I'll have that x plus 3.5 equals negative square root of 64.25. So subtracting 3.5 from my first equation, I'll get that x is equal to the square root of 64.25 minus 3.5, which equals 4.5156, which I'll round up to 4.516. However, on the answer sheet, they round down to 4.515. So x rounding up is 4.516. And my other x value, when I subtract 3.5 from both sides, taking away 3.5 from that negative square root, I'll get that x is equal to negative 11.5156, which I'll round up to 516, and on the worksheet they round down to 5.5. So negative 11.5156. 4.516. So my two solutions in number 23 are a positive 4.516 and a negative 11.516. And where they rounded down or simply truncated after that third decimal place, I rounded up, or rounded to the closest. Now, let's move on to the last problem, number 24. In number 24, my a value is a positive 1. So all I need to do is move the constant to the other side and then complete the square on the left-hand side. So n squared plus 19n equals 6 minus 66, which is a negative 60. Now completing the square, if my b value is a positive 19, my c value is going to be 19 over 2 squared. 19 divided by 2 is a positive 9.5. And when we square that, we'll get 90.25. So adding c to both sides, both the left and the right of my equation, I'll get n squared plus 19n plus 9.5 squared, which is 90.25. That's equal to negative 60 plus 90.25. And if you're more comfortable leaving this as 9.5 squared so that you remember that that will be your new b value when you simplify, for instance, n plus 9.5 squared, feel free to do so, because a squared plus 2ab plus b squared equals a plus b squared. And then negative 60 plus 90.25 equals a positive 30.25. So now when I take the square root of both sides, I'll get that n plus 9.5 is going to equal positive or negative square root of 30.25, which the square root of 30.25 is 5.5. So n plus 9.5 equals a positive 5.5, or n plus 9.5 equals a negative 5.5. So we're going to solve each of these equations. And we'll do so by subtracting 9.5 from both sides in each in order to isolate that n on the left-hand side. So n equals 5.5 minus 9.5, which is negative 4, and n equals negative 5.5 minus 9.5, which is negative 15. So my final solution on this worksheet, negative 4 and negative 15. If you have any questions, feel free to leave them in the comments below, and I or one of your peers will get back to you as soon as possible. Also, if you haven't done so already, please remember to like this video and subscribe to my channel. All likes and subscriptions are greatly appreciated. So before you move on, like, subscribe, and share.